Wow, this is truly amazing magic. How is this floating in the air? Did you see that piece of nylon holding it up? It was camouflaged with the ladder in the background. This is a Tensegrity model. It was made by Rob from the Xanadu channel. I'll leave a link in the description if you want to have a look at that video. Basically, it's two parts, and that top part is held up by nylon fishing line. So in this case, there is no nylon holding that piece up from the top that you can't see. This is more physics that is holding that piece up in the air. Anyway, in Rob's video, he gave a challenge to build one of these, and challenge accepted. Today I'm going to build one of these Tensegrity models. It's going to be similar to Rob's model, but a few little changes. I need to make some aluminium castings for the base, and I forgot to start the camera, so there's one and here's another one. I made two just in case one casting was no good. This tin can has ribs in it, so you basically have to rip the tin can apart to get your aluminium casting out. The Tensegrity model has two main parts. One is a base part and the other is the floating part. In terms of the base part, it'll be similar to Rob's. Start off with an aluminium base, one of these pieces here on the bench. Then you have the main shaft in the middle and the upper tension bar that goes through the main shaft here. So mine is different to Rob's as it goes through both sides. Now the floating part, I'll draw this on a bit of an angle to try and make it a bit clearer. We start with the cross support bar, and then we have vertical supports on each side of the cross support bar. At the bottom of the vertical supports we have the lower tension bars, and then at the top we have the base plate tension bar. Now these points A and B on the base plate tension bar have nylon string connecting to the base plate in these positions. These points C and D have nylon string connecting those points together as well, and that is what holds up the floating part. The nylon will go through 1mm holes, and there will be grub screws for each of those connections to hold it in place. I start with some 8mm round bar and also some 16mm round bar. I initially try to clean up that 8mm round bar on the lathe, but there are a whole lot of dings and dents and divots in it. So I decided to use some 10mm round bar and turn it down to 9mm. That gave me a nice clean surface. Once done, both ends of this upper tension bar are drilled out and tapped for M4 grub screws. Those screws hold the nylon in place. There are also some cross holes that need to go in here, but I'll deal with those later. Now I work on the main shaft, again turning it down to a nice finish. At this end I need to turn a step so that it can fit into the aluminium base. And I also need to drill and tap for a M8 screw which will be used to mount the shaft onto the base plate. I've turned it around and cut it off to length, and now I'm drilling and tapping for a M6 grub screw which will lock in the upper tension bar. Now I'm in the mill and I'm drilling a hole for the upper tension bar. I use a 9mm reamer because that is the size of our upper tension bar. I test that out and that is a beautiful fit. I start working on the aluminium base plate, and I'm turning a bit of a recess in here as well for three reasons. One is the casting had sunken in a bit, so that needs to be cleaned up. Second reason is that it will sit on the bench nice and flat. And the third reason is to give clearance for the bolt head, which will be under here. I've turned it around and I'm turning a little bit of a taper here just for aesthetics. A little bit more to clean up. Once that's done, I'm turning a flat area for the main shaft to sit on. I've drilled an 8mm clearance hole for the bolt, and I'm turning a little step in here for our main shaft to fit into. Again, that works great. You'll notice an extra ring on here. Good old numpty here dropped it and put a dent on the face and also a dent on the edge, so I had to put these chamfers on to hide them. Anyway, let's assemble it. Now I need to work on drilling the 2 holes at the ends here for the nylon to go through. I had to set up with my ER40 collet chuck because my ER32 doesn't have a 1mm collet. I was getting a lot of flex from this 1mm drill, so I decided to use a 1.5mm drill for these holes. That worked a lot better. This is the other end, and you can see that I've made this holder for the rod so that I can drill these ends. I test that out with a bit of nylon, and that looks like it works great. Next I start on the lower tension bars, and it's pretty much the same procedure. Tapping holes for the grub screw and cross holes for the nylon. These are separate bars, but they were made in one piece, so I just cut this piece in half and then I have my 2 lower tension bars. Then I start working on the vertical supports. This is a piece of home cast aluminium and I'm milling it into a square block. There's no plan or measurements, I'm just roughly working out where I should drill these 2 holes. I guess it's what looks good. So one hole is drilled out and reamed for 16mm. And the other is drilled and reamed for 9mm. I square off the ends on this block. I'm milling some cutaways here. This has nothing to do with the operation, it's just purely aesthetics. On 2 of those cutaways I widen them out with the wheel on the belt grinder. Then those corners are rounded off. I'm making the 2 parts out of one block, so I'm cutting the block in half. Each of those halves are tidied up on the mill and milled down to the same width. Then I drill and tap at both ends on both parts for a grub screw to lock the bars in. Again, there's no plan or measurement, so just whatever looks good, and then just sort of measure that distance. This is for the cross support bar at the top. I turn the outside down to 18mm. Then I cut the smaller diameters of 16mm for our vertical supports. Test that on there and it almost goes on, but this part is quite hot, so I think once it cools down that's going to fit on nicely. The excess is chopped off and the ends are squared up in the lathe off camera. I assemble the piece on the table. And that will fit around there somewhere. Now I need to make the base plate tension bar that comes out this way. But before I do that, I want to finish off the base plate. Here I'm working out where the holes are going to go for the nylon that goes to that base plate tension bar. And I drill the holes in the milling machine. Well, you're probably wondering what happened here with all these holes. Well, I had a few issues here. I drilled the first hole, that was fine. It's a little bit bigger now, but I'll explain that shortly. When I drilled the second hole, the bit broke off and that's stuck in there. I can't get it out. So I decided to drill 2 more holes on the other sides. And I marked those out initially, and then I realized that I needed a grub screw to hold the nylon in. So they needed to be moved in. So now I've got center punch marks there, and the hole is further in. I've drilled this hole out a little bit bigger, and I'm going to put this piece of aluminium in here and press it in. And then I'll chop it off, and I will turn down this whole outside circumference in the lathe again, and then that should tidy most of this up. I'll do that off camera. Okay, that's all done. It came out pretty good. Here is where the little plug is there. You can just see the outline. And on the other side, you can see the drill bit. I've also got rid of those extra punch marks. Now, I did have an odd thing here. There was a lot of little pits or holes in here, and I don't think it's anything to do with the casting. I think it's the way it was machined. The initial machining on this part and these other areas here, absolutely fine. So I'm not really sure what's caused those little pits there, but I'm just going to leave it like that. The last steps for the base plate are to drill and tap out each side of those 2 holes for the nylon to be locked in. I finish off the cross support bar. Here I'm milling a couple of flats. This allows me to mount the vertical support straight up and down. I turn it 90 degrees in the vise, and I drill and ream a 9mm hole for the base plate tension bar. I turn it back 90 degrees and drill and tap a hole for a grub screw to hold the base plate tension bar. Now I start working on the base plate tension bar. This is 10mm steel bar, and I turn it down to 9mm. I need 1.5mm holes at each end, and I'm taking it very cautiously here. This drill bit has been broken. I sharpened it up, but it is very short, so I'm just drilling a little bit and clearing out the holes. Same process down at the other end. Everything was going really well until
Houston, we've had a problem.
now that broken drill bit was stuck in there and I couldn't get it out, so I had to remake the complete part, and this is take 2. All the machining's done, and I wash everything down in acetone so that I can paint these 2 parts here. And the smaller rods will be blued with this perma blue. The larger rods are going to remain silver colour, although the ends on this rod here are going to be blued as well. Once blued, I thoroughly wash the parts off, dry them off, and then oil them up. Lastly, the 2 vertical supports are undercoated, and I apply a blue top coat. As you know, assembly is my favourite part. The vertical supports are put onto the cross support bar, and I align them up before locking them in place. Then the base plate tension bar is installed, lined up, and also locked down as well. Finally, the lower tension bars are installed. I'm using a drill bit here just to make sure that it's vertical up and down. Then those are locked in place. It was a bit of a tedious job putting the strings in, so I won't show all of this. But basically they're put in and locked in place. I come back and snip off the excess nylon. This was a great build, a lot of fun, and I mean it's a pretty cool little device. Basically this top structure is held up by these 4 nylon strings around here. The 2 long strings want to pull this top structure down to the base. However, the 2 short strings are stopping that from occurring. And basically all of the strings are under tension and the top part just floats there. Now I had some issues in the build. I broke off a drill bit in the base there. Also broke off a drill bit on one of the round bars as well. But those things happen and you just work through them. Anyway, I'm going to extend Rob's challenge and put it out there to make one of these Tensegrity models. You can make it the same as this one or the same as Rob's or have something completely different, but it's a cool little project, and record what you do and post it up on YouTube. It would be good to see if there are some other ideas that come through. Okay, so I hope everyone has a great day, and once again, thanks for watching.